Use A equals -1, 5, B is 2, -4, and C is -3, -3 to answer the following. The magnitude of A. The magnitude of A is the square root of 1 plus 25. So we square both the -1 and the 5. This is just like having the Pythagorean theorem. So we have the square root of 26. In letter B, it says find the magnitude of 2A minus B. So let's double A. We have -2, 10. And then we're going to minus the B, which is 2, -4. So -2 minus 2 is -4, and 10 minus -4 is 14. And then now we have to find the magnitude of this vector in component form. That'll be 16 plus 14 squared is 196. And then plus 16 is 212, so square root of 212. And that is 2 times the square root of 53. Letter C, we have the dot product between A and B. The dot product is multiply the x's, so -1 times 2 is -2, and then add that to multiply the y's. We have 5 times -4 is -20, so the dot product is -22. The angle between A and B. The cosine of theta is equal to A dot B, the dot product, so -22 divided by the magnitude of A, and the magnitude of A is square root of 26, times the magnitude of B, which is square root of 4 plus 16, so that's going to be square root of 20. -22 divided by the square root of 26. Oh, and I need parentheses around the denominator, so we'll insert a parenthesis there. And then times the square root of 20. We get -0.96, and now to get the theta, to get the angle, we take the inverse cosine of the answer, and we get 164 degrees. So theta is equal to 164.745. Are A and B orthogonal? Well, we've done A dot B, the dot product of A and B, and that is not 0. So no, A dot B does not equal 0. Given A is 4, -3, and B is -2, 9, find the component form of vector AB. To find the component form, we subtract -2 minus 4, x2 minus x1, and y2 minus y1, so 9 minus -3. We get -6, 12. Find the component form of vector V with the given magnitude and direction angle. So the vector in component form will be, we have 15 cosine of 38 and 15 times sine of 38, just like the unit circle, except it's not a unit circle. It has the circle has a radius of 15. So let's get 15 times cosine of 38. That's 11.82. 11.82. And then 15 times the sine of 38, which is 9.235. 9.235. Find 3 different pairs of polar coordinates that name the given point if theta is between -360, and that says 360, or theta is between -2 pi and 2 pi. So we can have 4, and how about a -4? And that would be 3 different points. So let's get an idea of where this is. 1, 2, 3, 4. It's on a radius of 4, a circle with a radius of 4. At 58 degrees. Let's say that's right there. So there's the point. Instead of going 58 degrees, we could go in the other direction. So I could take 58 and minus 360. So go clockwise instead of counterclockwise, and that'd be -302 degrees. Or we could go 180 from there. That would be that angle. That'd be this angle right here, and then go -4. So we could take 58 and add on 180 to that. So 238 degrees. So go 238 degrees, but instead of going along that angle, go in the opposite direction, which puts us in the same place. For letter B, we have 0.3 pi over 7. So that would be on a circle with radius 3. 1, 2, 3, 1, 2, 3, 2, 3, and then 1, 2, 3. There's a circle with radius of 3. Pi over 7 would be about right there. So we could have a positive radius and another angle, and we could have a negative radius and an angle that's opposite. So let's find the negative 3. Let's take pi over 7 and add on pi. That'd be 7 pi over 7, which is 8 pi over 7. So we could go over to 8 pi over 7, but then instead of going along that angle, go in the opposite direction. That's what the negative 3 would mean. Now we need one that's between negative 2 pi and 2 pi, so we could take pi over 7 and we could minus 2 pi, which is 14 pi over 7. So that would be negative 13 pi over 7, and that puts us in the exact same spot. Here we have the limacons and the circles and the roses. These two right here, those are circles. They finish in pi, and with cosine, that's going to be a right or a left circle. In other words, to the right or to the left of the origin. And with sine, that one's going to be up or down. And we would count by pi over 2's to graph that one. The one to the right, these are the cardioids. Because if you count by pi over 2's, the lowest r will be equal to 0. So this one will touch the pole. These finish in 2 pi. And cosine, the wide side would be to the right or the left, and the wide side on sine would be up or down. These are inner loops. And r is going to be less than 0 for this. R is going to be negative somewhere when you count by pi over 2's, and you have to go all the way to 2 pi for these as well. These are, this one right here is going to be a limacon with a dimpled. So dimpled. Dimpled because 6 is bigger than 5, but it's not twice 5 or more, so it's not 10 or more. Dimpled, we count by pi over 2's. You have to go all the way to 2 pi, and r is always going to be positive. With these down here, this is going to be the convex, and r is certainly going to be positive, but this number right here is more or equal to twice the 5. We want to count by 2's for this as well, and these finish in 2 pi. Here we have roses, but we have an even number. When it's even, in this case, there will be 4 petals, or we double the number to find the petals. We have to count by, or we have to count all the way to 2 pi, and in this case, we'll count by pi over 4's. If that was a 4, then we'd count by pi over 8's. Here we have an odd coefficient of theta, and because of that, there will be 3 petals, or the same amount when that number is odd. We only have to count 2 pi, and we'll count by pi over 6's. Graph r equals 3 plus 3 cosine theta. We will count by pi over 2's, so we have theta, r. So 0, 1 half, 2 halves, 3 halves, and 4 halves. So cosine of 0 is 1, so we have 6. Cosine of pi over 2 is 0, so that's 3. Cosine of pi is negative 1, that's 0. That means we're going to have a cardioid. Cosine of 3 pi over 2 is 0, so we have 3. And then we're back to 6. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 0, 1, 2, 3, and then back to 6. So this is going to loop around. It's going to bounce off the pole. It's going to go a little bit wider and then loop around like that. Here we have r equals 5 cosine of 3 theta. This is a rose. We have theta and r. We're going to count by pi over 6's, but we only have to go to pi. So 1/6, 2/6, 3/6, 4/6, 5/6, and then 6/6, which is pi. Now cosine of 0 is 1, so we have 5. Cosine of pi over 2, we'll get pi over 2 when we plug pi over 6, is 0. So we have 0, then negative 5, 0, 5, 0, negative 5. We start out with 0, 5. So 0 degrees, 1, 2, 3, 4, 5. And then pi over 6 is 0. So we're back to 0 once we hit pi over 6. Then pi over 3 is negative 5. So along pi over 3, we have 1, 2, 3, 4, 5. So we loop around to this one. Back to 0 at 2 pi over 3. So back to 0 here. Then 5 pi over 6 is 5. So we loop around to 5, back to 0, and then pi is negative 5. So back to there. Convert from rectangular to polar and vice versa. So we have this rectangular, we want to convert to polar. So r squared is equal to 4 plus 25. So r is equal to the square root of 29. So we have the r. And now we need the inverse tangent of 5 over negative 2, but we got to keep in mind that this is not in a principal quadrant. 1, 2, 3, 4, 5. That point is up there. So let's take the inverse tangent of negative 5 halves. Inverse tangent of negative 5 divided by 2. That is negative 68 degrees. That's down here, so we'll have to add 180 to this. So add 180, we get 111. So the radius is square root of 29, and the angle is 111.801 degrees. This is the polar. We have 6 and pi over 3. So the x is 6 times cosine of pi over 3, and the y is 6 sine of pi over 3. So that's 6 times the cosine of pi over 3 is a half, and the sine of pi over 3 is square root of 3 over 2. So we get 3 and 3 square root of 3. Write each equation in polar form. We have x squared plus y squared minus 8y plus 16 equals 16. X squared plus y squared is r squared, and y is r sine of theta, and we can subtract 16 from both sides. So let's get this to the other side. We have 8r sine of theta, and then divide by r. So r equals 8 sine of theta. Write each equation in rectangular form. Let's multiply both sides by r. We have 5r cosine of theta. R squared is x squared plus y squared. That'll be 5x. Then we have x squared minus 5x plus something, plus y squared is equal to 0 plus something. 5 divided by 2 is 5 halves. 5 halves squared is 25 fourths. So we have to add 25 fourths. This becomes x minus 5 halves squared plus y squared is equal to 25 fourths. Theta equals pi over 3. We can take the tangent of both sides. We have tangent of theta equals tangent of pi over 3. Tangent of theta is the same as y over x, and the tangent of pi over 3 is square root of 3. So we have y equals square root of 3x. We can square both sides. We have r squared equals 64. That's x squared plus y squared equals 64. And for this one, 6 secant is the same as 6 over cosine of theta. We can multiply both sides by cosine, and our cosine is x. So we have x equals 6.